Hi everyone, this is Jayanthi Thalapathi from Gateway the Complete School. Today we are going to see about the paper 970122. So this is for AS level, May-June 2014. So in this paper we are going to see question number 5, which is an organic chemistry question. Okay, so you see this question. A hydrocarbon P with the formula C6H12 readily decolorizes bromine. On reaction with hard concentrated acidified potassium permanganate solution, product Q is obtained. So, Q gives an orange precipitate when reacted with 2,4-dinitrophenyl hydrogen. So 2,4-DNPH reagent but has no reaction with Tollens reagent. Okay, so 2,4-dinitrophenyl hydrogen is 2,4-DNPH. Okay, so now we knew few things about hydrocarbon, right? Actually, if it is CnH2n, the formula shows the general formula CnH2n, C6H12 shows. So this is obviously, we know this is alkene, right? So alkene readily decolorizes bromine. So bromine and KMnO4, these are the two reagents which helps us to find out alkene, right? So it's a confirmatory test for alkene actually. So if it is decolorizes bromine and KMnO4, then that compound is called alkene. So C6H12 is, so carbon here 6 carbon atoms, so it is hexene, right? So here on reaction with hard concentrated KMnO4. So hard concentrated KMnO4, with the hard concentrated KMnO4, what product you will get? Q. So I said it oxidizes, right? This will oxidize the alkene. When it oxidizes, you might get a methanol also. So if oxidizes, while oxidizing, it breaks C double bond C. So you can say they break C double bond C, or otherwise you can write thus it gives you CO2. I mean the methanol oxidizes to CO2. Okay. The other product is pentene, pentanol, pentanone, like that. So that you are going to test now. And the next one, Q gives, and so you are getting Q. That Q gives an orange precipitate when reacted with 2,4-dinitrophenyl hydrogen. So if you add 2,4-DNPH, you are getting orange precipitate. So which will give you orange precipitate? Actually, for what reason we are using 2,4-DNPH? To test whether the compound is a ketone or aldehyde. Okay, it's actually if a ketone or aldehyde, then only you will get orange precipitate. If not, if there is no carbonyl group, you will not get orange precipitate. Okay, so that is why you are getting orange precipitate. So obviously it should be a ketone or aldehyde. Then you need to confirm, is it an aldehyde or ketone? So the continuously they have given but has no reaction with Tollens reagent. So if it reacts with Tollens reagent, then it is aldehyde. You will get a silver mirror appearance. But if there is no reaction, it is ketone. So you are confirming it as ketone. So what you need to write over here? Number one, decolorization, right? So it is C double bond C, I mean alkene group and unsaturated. And number 2, it breaks C double bond C, right? And number 3, it should be a carbonyl group, right? And we are confirming Tollens by using Tollens reagent, it is ketone. Okay, there is no reaction, so we confirms it is ketone. Clear? So now draw the skeletal formula of P and give its name. So P is a alkene. So you can draw like this, C double bond C, like this. So they are asking skeletal formula. So how will you draw skeletal formula? Like this. So this shows 2 carbon atoms over here and 4 carbon atoms. So 6 carbon atoms. So C6H12. Okay. So if you calculate, you will get to know. When many forms are there, so 1 is enough. So name of that P is hexene, right? Hexene. Hexene, the position also, you can write the position also. For example, if it is between 2 and 3, then 2 hexene, hex 2ene, like that. And if it is between 3rd and the 4th carbon atom, hex 3ene, hex 4ene, like that you can write, right? So the position, you need to mention the position according to the picture, according to the skeletal formula. And draw the skeletal formula of Q. So skeletal formula of Q. What is Q actually? Q gives orange precipitate and has no reaction with Tollens reagent. So obviously the Q is ketone, right? So ketone it can be, because already we have seen one methane group becomes methanol. Methanol oxidizes to acid, we have seen. So now the 5 carbon atoms. So you can draw it like this. 4, 5 carbon atom with double bond O. So 2 ketone, 2 pentanone, right? Or pentane 2 one. So 2 pentanone or 3 pentanone, like that. You can change the position, okay? But they have asked only one structure, so you have given this. So 1, 2, 3, 4, 5 carbon atom, double bond O, pentanone, okay? And the next question is, there are several structural isomers of P that also decolorize bromine, but only 4 of these structural isomers exhibit geometrical isomerism, cis and trans isomerism. Give the structures of any 3 structural isomers. Any 3 structural, you can draw. P means it's hexene, right? So hexene, how many ever you can give, you can write, but you need to listen to this, cis and trans. So cis trans means same side. The simple one should be one side and the complex one should be in the other side. That is cis and trans, right? Cis. Trans means like mixed. So we will see now. We will see few examples. Here they have asked you 3 structures. Okay. So number 1, for example, you can take C2H5, CH double bond CH, C2H5. Okay. If you take this structure, how will you write as cis? Cis is H double bond carbon H. So both the carbon atom has H, right, over there, and C2H5, same, C2H5. This is cis. And then what is trans then? Trans is carbon hydrogen, simpler one over here and the complex one over here. And according to that, here the complex one and here the simple one. Okay. So this is according to this example, this is cis and this is trans. Okay. So like that 3 isomers they are asked. So 3 means the second one you can write CH3, CH double bond C, CH3, C2H5. Okay. This is like CH3 over here and C2H5 over here. Okay. So here and over here CH and CH3. Okay. Like this. CH and CH3. So if you take this, the simpler ones over here and the complex ones over here, higher one over here. So this is cis. So trans, according to that you should change, right? And what is the third example? CH3, CH, double bond, CH, CH2, CH2, CH3. So how will you write this actually? Actually this is here 2 carbon atoms and here 4 carbon atoms. You can take it as propyl as one branch. So like this, C, double bond C, H, and propyl C3H7, and over here H, CH3. Okay, so these are cis. So according to that, trans you can write easily. Trans C double bond C. If it is H over here, and here the complex one C2H5, and here CH3, CH3. So these 3 examples gives you cis and trans structure. Okay, so C, if you write H simpler one over here, you can write propane over here. Okay, propyl. So and here hydrogen and here methyl. So I think now you understood the concept, right? So the first one, the 3 carbon atoms over here and the double bond, and again 3 carbon atoms. So you can write the cis and trans like this, but they haven't asked you to write cis and trans, but still I have showed you how to write cis and trans. Okay, yeah. So like this you need to try this. We will see the other questions later. Bye bye.